Okay, Mario, once again, I wanted to make a note in this video that I actually ran another test of the motor, this motor right here that I had mounted with a 13-inch rotor. This is the rotor that I employ on some of my sub-micro helicopters. It's a 13-inch rotor. And so I did some tests in the other short videos, and you can see that, but my kV of the motor was coming out at 308 308 is the kV of the motor. I ran another test using the drill and voltmeter method, as many other videos show. You can find the formulas on the internet. Plugged it into to the formulas using the values that I was getting from the voltmeter. Set to AC volts and to read also frequency. And so I wanted to just quickly showcase this here. These are the figures that I got: 175 hertz, 1.8, 1.9, 1.8. So I basically added those up, divided by 3 to get an average of 1.83 volts AC. That's the RMS value. I plugged, I used the formula for RPM, 60 times 175, the hertz, times the frequency, divided by half the number of poles, in this case 7, which is half of 14 poles that of the motor. I ended up with a 1500 RPM. Then I used the peak voltage. Peak voltage is, I took this figure right here, about 1.8, 1.83, multiplied that times the square root of 2, and ended up with 2.58 volts. Plug that into this formula here: kV equals RPM divided by peak voltage times 0.95. This 0.95 is just to introduce a little more of an error there, to account for some error. And so that came out to 625 kV. This is actually the actual kV of the motor using this method here. Now, in order to prove my point here, to make sure that I was doing this right, I actually took a motor. This motor is rated at 700 kV. Did the drill steps here, just ran this with a drill and measured once again the frequency and the voltage AC RMS 1.6 volts, plugged that into the formula, and it actually came out to 700 kV. So I just want to capture this. I made a full video. Check